Hello, Mr. Betts here. Let's take a look at another example of a power series, and we want to determine the interval of convergence for this power series. So we're going to start with the ratio test. So the limit as n approaches infinity of the absolute value of the n plus first term divided by the nth term. Remember, we're just multiplying by the reciprocal of the nth term. And we want to cancel what we can. The x minus 3's, I think, are the easy part here. We have one more of those in the numerator than the denominator. What we have here with the factorials, this is 2n plus 2 factorial. And if you think about what that is, that's 2n plus 2 times 2n plus 1 times 2n times 2n minus 1, and so on. And so if we write out that factorial till we get the factorial we have in the numerator, now we can cancel the 2n factorial with the 2n factorial. And so let's rewrite our limit. So this is going to be the absolute value of x minus 3 can come out. And then we have the limit as n approaches infinity of numerator. We don't have anything left because the x minus 3 went out front. In the denominator, we have 2n plus 2 times 2n plus 1. And that limit, as n gets really big, the denominator is getting really big while the numerator stays 1. And so that limit is going to be 0. So it's going to be absolute value of x minus 3 times 0, which is just 0. So remember, the ratio test says that if the ratio, this value that we get here, this limit, is less than 1, then the series converges. And no matter what we plug in for x, we're always going to get 0 for this limit, which means that no matter what we put in for x, the series is going to converge. So the interval of convergence on this one is a nice, easy one. It's all real numbers. So we could write it like that. We could write it as that interval right there. As an inequality, we can't really write it because we don't want to write this. Negative infinity is less than x is less than infinity. That doesn't make any sense. But the interval of convergence is all real numbers. We might also say, if this was a radius of convergence problem, we might say that the radius of convergence is infinite. So that would be the appropriate way to answer that question. But any value that we plug in for x here, we are going to get a convergent series. Now, I want to point out why that happens. Notice that the factorial in the denominator, factorials grow very, very quickly. In fact, factorials grow faster than any other kind of function. And in the numerator, we have an exponential function. So no matter what we put in for x, the factorial is going to end up growing faster than the exponential. And so the denominator is going to dominate and the terms are going to approach 0. So because the terms approach 0 and because they approach 0 so quickly because of the factorial, then when we add the terms, we are going to get a finite sum. So no matter what we plug in for x, we get a convergent series. So the interval of convergence is negative infinity to infinity, or all real numbers.